So in the last video, we talked about the binomial theorem, and we talked about the idea that the binomial theorem follows a set pattern such that it starts from the first term, which is a, to the power n, and then it moves on and proceeds till the last term, which will be b, is to the power n. And it moves in between these terms through a process whereby you drop a and then raise b. So before I proceed on to this whole big idea of other patterns that are in the binomial theorem, I want to expand more on the idea of dropping a and then raising b. So when you drop a and then you raise b, it means that, well, wherever there's a, it means that a will be powered by a certain exponent minus 1. And then it will mean that b will be powered by a certain exponent plus 1. Now, for an example, let us look at a plus b, and then let's say all of that squared. It will be equal to a squared plus a b plus b squared. Now, we understand that what's supposed to happen is that ab is supposed to have a coefficient of 2. But now let's just put it in this form at the moment, just in the meantime, for the sake of this explanation which I'm about to give. So how did they go about getting all these terms? Now this is where the idea of dropping a and raising b comes in. So it will be such that a equals 2. So first, a will be powered by 2. And then we know that in order for it to only be a squared, it was such that b was powered by 0. And then it was plus a, and then this term, like the first a, we know that it was powered by 2. So it will end up here being 2 minus 1. And then from there it will end up being b, since b was actually powered by 0. It will then end up being b powered by 0 plus 1. And then it will be such that we'll get plus a powered by, well, this a here will end up being powered by 1. So we'll get here 1 minus 1. It will be a all to the power 1 minus 1 multiplied by b. So if we add 0 to 1, it will end up being 1. So it will be such that it will be 1 plus 1. b will be powered by 1 plus 1. So this is what happens as the pattern continues. We'll get a squared b. Well, in fact, let me do it this way. So anything powered by 0, we know that it will equal to 1. So instead it will be a squared multiplied by 1 plus a is to the power 2 minus 1. Well, we know that to be a is to the power 1. And then from there it will be such that it's multiplied by b is to the power 1. And then plus, well, a is powered by a is powered by 1 minus 1. So 1 minus 1 actually equals 0. So it will be such that it will be a is to the power 0, and then b is to the power 1 plus 1 equals 2. So it's b squared. So then it will be such that it will equal to a squared plus a b plus, well, a to the power 0 is going to equal to 1. And so from there, we'll get b squared. And so what happens next is that it will equal to, well, a squared plus a b plus b squared. So this is how they got to all these terms. they followed this entire process as I've actually stated. So, well, why did I actually say that? We know that anything powered by 0 will be equal to 1. Well, let me demonstrate it using this way. Let's say that we have a, well, according to the laws of exponents, well, if we divide exponents if we divide powers of the same base, what happens is that we keep the exponent the same. And then from there, after we keep the exponent the same, we subtract the exponents. So we keep the base of a being the same, and then we subtract the exponents, which is 2. So it will end up being a equals 2 minus 2, which is a is to the power 0. So this is another way of doing it. So this is, we're dividing one thing by actually the same thing. So since we're dividing a squared by a squared, which is pretty much the same thing, what happens is that the a squared and the a squared cancel. So you end up getting 1. So this is where this idea of anything powered by 0 equals to 1. And so it is actually, as I've stated now on this whole idea on the last video of dropping a and then raising b, where we get that when n is even, in the middle term, we'll find that a and b are both powered by identical halves of n. And so let us look at another expression. Well, pretty much the same expression, a plus b, but this time it's all powered by 6. So what you'll get is that you're going to get a is to the power 6 multiplied by a to the 5th, b plus, oh, sorry about that, I actually intended to say plus. So again, it's going to be a to the 6th plus a to the 5th, b plus a to the 4th, b squared, plus a to the 3rd, b to the 3rd, plus a squared, b to the 4th, plus a, b to the 5th, plus b to the 6th. Now watch what is happening here again. It comes back to this idea that in the middle term, what happens is that a and b are both powered by identical halves of n. So our n is 6. And we know that the half of 6 is equal to 3. And how many terms here are being produced? 1, 2, 3, 4, 5. So it's going to be 1, 2, 3, 4, 5, 6, 7. And so since there's 7 terms being produced, our middle term is going to be a to the 3rd, b to the 3rd, because there's an equal gap of 3 in between all these terms. 1, 2, 3, and another one, 1, 2, 3, and then from there we come up to then the middle term. So from there, this proves again this whole idea that in the middle term, when n is even, well, a and b are going to be powered by identical halves of n. So now let us look at this pattern in detail once again. So let us look at this statement, a plus b is to the power n. So where n is either odd or even, there's always a